Okay, so we've got an assembly question here. I'm going to be using this sheet to help you through it. This is a trace table, so you either have to write them or you have to do the trace table with it. You'll notice there are binary values followed by the denary value on here. That's just common practice, all right? Just remember when you are programming questions on what to look for, right? So what we've got here is an example of a bit of code, but it says the program takes values from register 1 and register 2 and stores them in register 0 and 1. It says complete the trace table to show the results of executing the program in the code above with the initial values in R1 and R2. So 34 is R1 and 6 is R2. All right. Each register can hold a 16-bit value. You may find it easier to understand the operation of the program if you write the contents out in both binary and decimal. You may not need to use all the rows. So just bear that in mind, because sometimes people freak out in an exam and get to the bottom because they've not registered this, and they think they've got to fill out every single row. All right. So let's start the program. All right. So they've already done this bit for us. So in register 1 is 34 and 110 is in register, 6 is in register 2. Now, what we've got to do is if we have a look here, it says compare. So we'll start up here. They've already been loaded in. We're going to compare register 2 with 0. Okay? So we're comparing register 2 with 0. Is it equal? So register 2, so we're starting with 6, all right? It's not equal, is it? Right, so we don't need to go to exit. That's what I'm trying to say, all right? So don't get mixed up. Now, it says move into register 0 the number 0. All right? So what we do is 0, 0. I've done that step. Move into register 3 the number 1. So I'm going to write over here 1. There you go, 1 mark. Now, I've done that. Remember, assembly code is sequential, so we're just going to go straight into this label.
Yeah.
So now, are you okay?
Yeah, it was your mom.
Right. So let's have a look. So now we're moving to LSL. Let's look at what LSL means. It means left shift the value stored in register N, so the N value, however many are in the operand, so you're shifting this value, however many, and storing the result in that register. So this says left shift whatever is in R2, all right, by one place and store it in R2. So if I write this out for you here, I'm just going to write out R2 on the side here. You might want to do that if you're stuck in an exam situation freaking out. You might want to do it separate, working out somewhere before you put it into the table. So if I've got 1, 1, 0, that's going to be shifted by one place. LSL means left shift, all right? So it's going to become 1, 1, 0, 0. So you're going to pad it out. And then it stores the result in R2. 1, 1, 0, 0. What value does that now become? So it was 6, 12. Okay, so I've done that. So I might have to go back up here in a minute. All right, we're just going to work through this. Then it's left shift the value in R3 by 1. So that now becomes 1, 0, which becomes 2. All right. I am comparing R2 to R1. So I'm comparing 12 to 2. Oh, sorry. My bad. Comparing R2 to R1. So 12 to 34. So I'm going to compare 12 to 34. Is 12 less? Is 12 less? Yes, 12 is less than 34, so we go back up here. So I need to iterate. So now R2 is going to be shifted again, which becomes 1, 1, 0, 0, 0. What happens when we shift one place? Times it by 2. So we've done that one again. R3, 1, 0, 0 becomes 4. Right. Now, compare R2 to R1. 24 is still less than 34. So compare R2 to R1. Is it less? Yes, so I go back up to move less. Right? Shift R2 again, which becomes, what does it become now? 48. What does this one become? 8. Alright, so I've done that, but now I'm going to compare again. Is R2 less than R1? It's not this time, so it's not. Is it equal? No. Alright, so now I'm going to LSR, just be careful you don't get them mixed up, means shift right. Okay, so we're going back one place now. So that now becomes, so we're going to do R2, shift it back one place, so it becomes 24 again. This one we're shifting R3 back one place, now becomes 4. So I've done that and that. Now I'm in the main loop. Alright, it says compare R1 to R2. So 34 to 24. Alright? Is 34 less than 24? So I'm going to add R3 to R0. So what's in R3? 4. I'm going to add that to 0, R0, which now becomes 4. Right, so I've done that. Then I'm going to subtract the value of R2 from R1. Right, so 24 from 34, which becomes 10. So subtract that. Alright. Now, the next thing I need to do is I'm going to go down here and I've got to do an AND logic on R3 and store the result in R4. So what's in R3? Yeah, so look, I'm going to write this out to show you how to do this. So I've got 1, 0, 0 in R3, and I'm going to do an AND on it. So therefore, if I do an AND on this, it's just 0, which is then placed in, because remember, if it's 1 plus, because that's that, don't forget, remember with an AND gate, both must be true to be true. But that number there is the denary number, so therefore 0, 0, 1. So 0 plus 1 is 0, 0 plus 0 is 0, and 0 again. So therefore, in R4, we now have 0, 0. Right, now compare R4 to the number 1. Is it equal? Is R4 equal to number 1? No, it's not. So I've compared. But now I've got to do a right shift of R2 by one place, which now becomes 12, because, yeah, right shift is a division by 2. So that now becomes 1, 1, 0, 0. Alright, because that was shifted by 1, so that becomes 12. But then I go in here, and I'm going to right shift R3 by 1, which now becomes 2. 2. Alright, compare R3 to 0. Are they equal? Because that says not equal, yeah. So now we go back to main loop. So we're back up here. Right? And I'm going to compare R1 to R2. And is R1 less than R2?
Yes, it is. R1 is less than R2. R1's 10, R2's 12.
Oh yeah, I went to the wrong one there. So 10, so therefore we branch to skip. So we're here now. So we're going to AND to R3 again.
Still 0.
So it's still 0. Alright. So that's still 0. Compare R4 to number 1. Are they equal?
No.
Nope. So I'm going to left shift, which becomes, right shift, which becomes 6. And then I'll go down here, do the same here, becomes 1. Now I'm going to compare R3 to 0. They are not equal, so I go back to the main loop again. Up here. Alright. Compare R1 to R2. Is R1 less than R2? No, it's not this time. So we're going to go add R3 to R0 and store it in there. So I'm going to add R3 to 0 and store it in 0, which becomes 1 plus 4 is 5. So that's, I'm going to subtract R2 from R1, 6 from 10, which gives you 4. Alright, we're nearly there. Alright, so we've got my 5 and my 4. Now I'm going to AND R3 with a 1 and store the result in R4. What's 1 plus 1? When we AND them. Who just said that? When we AND them, it's 1. Thank you. Alright, so down here, and the result is stored in R4. So I've got a 1 here. Alright, and then compare R4 to the number 1. Are they equal? Yeah, so jump straight to this. Then I'm going to shift to the right. R3 is going to shift to the right, which now becomes 0. And it says, compare R3 to 0 if they are the same. Yeah. So it doesn't go up, they're the same, because that says not equal, so we go to the halt. That is the program done. Alright? I know it's taken me a while to explain it, but I want to show how you can just follow it. So you just follow it, making sure you use these steps, and making sure if it's LSL, it's left. If it's LSR, it's to the right. So that's a trace table walked through.